Okay, let's begin. So welcome everyone. Good morning. My name's Andrew Flattress, the Braille Product Manager here at Humanware. And today's webinar, we're going to cover create, learn, and code with tangible results. So during this webinar, participants will identify two applications for reviewing code on a refreshable device. Participants will identify two different ways a user can locate errors in lines of code. And attendees will observe a new Braille-centric application that will display or directly run code that will give you tangible and auditory feedback. And lastly, attendees will observe some of the challenges that we can face using off-the-shelf coding applications. So we're going to start with what is coding, and coding is becoming a big buzzword. I'm sure in a lot of the education fields, it's quite scary, overwhelming, but there are several types of different coding languages, and I've listed a few here on my slide. So we look at Python. It's a high-level coding language, and this is commonly used in education. There's JavaScript, there's Java, there's C, there's C++, there's many other different languages, and they're all used to create websites, applications on your mobile phones, or any other software applications for that matter. And in addition to these different types of languages, there's various methods of interacting with code, how you actually start coding or actually coding software. And these are block methods and text methods, and we'll touch base on those in a couple of slides. But mostly all of these languages, code languages, they all share that same common goal. And of course, it's a programming language to get a computer or a device to behave how you want it to. Some of the common challenges then that we can face. Now, teachers, TVIs, a lot of the times we're lost of how to include our blind students or vision impaired students on how to start coding. When we look at our ICT lessons, how can we get our students involved? And some of the problems that we face here is a lot of the applications of coding have some form of accessibility, but certainly from a Braille standpoint, they lack a lot of optimization, shall we say. So what you'll find is in these applications, they class them as accessible, but they're not very usable. So you still have some challenges that you have to try and find certain buttons, or some of the labels may not be correctly labeled as well. There's a requirement of a lot of double tapping, triple tapping, certainly if you're using iPhone's app. So things like Scratch, for example. And of course, then the auditory, it lowers the efficiency. So certainly when Braille is not available, you're relying on that auditory. And then, of course, that's another issue in itself. In some of these applications, and I'll mention a few, Scratch is one of them, the Visual Studio, Android Studio, you're restricted in using computer Braille. So when you're using a Braille display, perhaps with one of these applications, you'll have to type in computer Braille, although you'll be able to get your feedback in Braille in contracted Braille. But nevertheless, it's just another method that you'll need to learn when you're introducing young learners to these main applications. Curriculum and activities, they're all highly visual based, right? So again, these applications, when you're trying to create code and create something, it's very much visual. And so how can we get our visually impaired student involved in that situation? This certainly leads to the unequal participation. So for that young student, it certainly affects them. It lowers their engagement rate. And perhaps you may have to give them another task or something else to do rather than the coding. So they'll never get into coding, or they'll lose interest in coding at a very early stage. So these ongoing barriers that we face, we need to problem solve. How can we better introduce these different coding applications, or getting coding into a student at a young age? And, there are some tools, and we'll go into some tools in just a moment. But one last common challenge is, of course, text-to-speech. So text-to-speech is a common tool that we all use for our blind students, if you're using, whether it's a note taker or whether it's a Braille display and a screen reader. But that, of course, becomes a challenge because of the verbosity levels. So again, imagine you've got something going in on your screen, you've got this long bit of code, it's just going in your ear, and it's very difficult to take all of that in, like asterisks, comma, all of these different syntax information going into one ear. So it is very difficult at this stage. So that's why, again, having that braille reinforcement is critical for when we want to promote coding for our young students. But despite these common challenges, though, there are some successful developers who are blind. So they have actually adapted to what was available at the time. So having only audio with a screen reader is something they have learned to adapt. It's something that it's not for everyone, I have to say, but you can adapt to it, but you'll still face some of those challenges. So I've got some interesting statistics here, actually. So in the last few years, there's been a huge demand for software engineers, right? So we see day in, day out, a lot of technology, new applications, new software. So, this technology is rapidly changing, which has led to a shortage of workers in this field. And just to let you know, USA alone, there's over 920,000 unfilled positions for software engineers. And out of that part, there's only probably 165,000 potential applicants. Some other statistics here. So on Stack Overflow, from a recent survey they did back in 2022, over 70,000 developers were surveyed. Out of that 70,000, just over 2,500 responded that they had some kind of disability. So that represents about 4% of that software engineers have a disability. Now, from that 4%, 1.7% were blind, giving us potentially a total of 25 blind software engineers out of that 70,000 candidates. So again, equivalent to about 1 out of 2,800 software developers is blind. Now, why is this so low? It's a very good question. But despite these kind of low statistics, it shows the potential and opportunities that are available for our future students. And I think the key takeaway here is, why is it 1 out of that 2,800 software developers are blind? Is it through the lack of resources available for anyone who's blind to learn code, the lack of engagement, and how getting the young learners to continue learning about coding? In my own opinion, I believe that there has not been sufficient tools for blind people to gain interest into this field. A lot has to do with the engagement, as this is key in obtaining interest in such personal development. The minute you start losing that engagement level, then they've lost interest. They don't want to continue that. So really, I believe it's about having the right tools to do something. So let's have a look when to introduce coding to students. And, we get this a lot in terms of questions. So we know that it's becoming present in the vast majority of education curriculums, certainly in the UK. So back in 2013, the national curriculum was altered to replace the ICT lessons with a more up-to-date computer curriculum. So coding is very much established here in the UK. Elsewhere in the USA, for example, it's kind of just beginning. And, in a lot of these schools, they do have some extracurricular coding clubs and activities. This is quite common in elementary school. And students as young as 5 years of age are now learning how to code in some form. Okay, so I'm not talking about learning how to script code, but learning some of the principles, which we'll touch base on. Then we get a lot of the young enthusiast software developers. So some of these students, they want to learn how to code. They start asking questions about, wow, I'd love to be able to program something on my Braille Note Touch. And this is, again, a question that comes up a lot at Humanware, is how can we program something for the Braille Note? Today's kind of education space, a lot of it is around gamifying. So we're seeing that a lot as well. So gamifying allows a student to learn whilst they kind of feel like they're playing. And a lot of these applications are sighted peers, they're playing these educational games. But for someone who's blind, they're not able to participate. But learning to code is like learning a new language, I say. So the younger that you can get them on to learning code, the better that they will adapt to it. And it's very much the same when you're learning a language. If you learn a language at a young age, you'll adapt to that language quicker and sooner. But providing you have those right tools, there's no reason why you shouldn't allow that student to be introduced into coding. There are some tools that are available, and I'll touch base on the next slide about one of the assistive technology devices that you can use to introduce coding to your students, and not just blind students. This product that I'm about to announce in a minute is not just for someone who's visually impaired. It's a product that is for all. Certainly a young age, they'll have some real good fun learning how to code with this device. And this device is called CodeJumper, which you may have heard of. Our CodeJumper really gets you started into learning some of those principles of coding. It's a great tool to start off. It introduces problem solving, critical thinking, analytic, spatial concepts. So this device, consists of about 16 or so little individual pods, and you plug these pods into this kind of main kind of device. So these pods kind of plug in with an audio jack, and it starts creating like a thread, or creates a chain. And there's all kinds of different tasks, and there's a lot of curriculum documentations that is available as well. There's a full curriculum available. And again, it's just really getting the whole principles about learning how to code. How can we code, for example, the Twinkle Twinkle Little Star song or other kind of songs, and you'll then be able to then improve that code. But what's important here is that there is a missing thread, and that's, of course, the braille reinforcement. But you can actually install CodeJumper on the Braille Note Touch. So if you have got students that have the Braille Note Touch Plus, you can install CodeJumper. Now, you won't be able to control CodeJumper from your Braille Note, but what's important there is you'll be able to read the Braille. So when you're changing some of these pods, you'll be able to read the threads of what that pod has been set to. One other thing to announce on CodeJumper side of things is I'm also led to believe, and I'm pretty confident that will happen at some point, they will introduce a Python viewer. Now, this will be fantastic because it then transitions that young student from just coding with these pods and block coding to then understanding what's happening behind that from a syntax point of view in text script. And of course, that's what you need in terms of progressing with coding, is how I can code in syntax. So on that note, let's have a look at those two different methods that I mentioned. So we have block method and we have text, and CodeJumper is using the block method. So I'm just going to go down the list of some of the disadvantages and advantages of block and text here. So we have a look at block. So we have I've got two images here on the screen. I've got one image that's showing the block text with different color boxes, and another image with kind of a black background with various different colors of text strings. So if we look at block is traditionally used for new students. It certainly is a more simple approach. However, it's not accessible, right? Someone who is actually visually impaired or blind, they're not able to potentially drag and drop these blocks. Now, although these blocks are pre-made blocks of code, which makes it simple, someone who's blind is not able to really drag and drop those codes. The other piece about block is it's limited in your creativity. So this will only take you so far, and you're not expecting, and you will not use block codes when you're actually in a profession of coding and programming. So as I mentioned, it's not the most accessible. However, this is where CodeJumper is unique in that, that CodeJumper does use block, but they have made it more accessible and more usable by using these tactile pods. Now, on the text side of things, this is often seen as challenging. When you look at all of this text, it can be very scary and overwhelming for us. One thing to remember, if that are supporting blind children, we're not there to teach code. This is where the ICT teacher is in place. What we're here to do is provide the tools on how we can use that learning and use the actual Braille Note or CodeJumper to kind of learn how to code. Now, text is transitions into what you'll be expected to use in the real world. So when you want a profession in coding, text-based is what you'll be using. It certainly will expand your knowledge and more likely to comprehend and build on your skills. And certainly the sky is your limit here. So this is, as I said, this is what you're expected to use, and you can do all kinds of stuff with the text-based coding. It is a familiar syntax, so, common language, word, characters, and symbols, that native language that we all know. So it may not be as scary as you think. Once you start learning some of the principles of coding, transitioning to the text-based may not be as scary. So let's have a look at Braille tools then, wise. So like all literary skills, the Braille plays an important role when it comes to coding. As I mentioned before, there's been a lot of coders, software engineers out there to date that have used TTS and have had some successful careers and working with the likes of Google and Microsoft and Apples of this world. And as I said, they can be very successful, but still there's a lot of challenges and it's not for everyone. And this could be the possible reason why we only see 1% of software engineers who are blind, because of the lack of tools and engagement at that very young age. But Braille displays can be used today with current coding applications. So those applications that I mentioned, you can certainly use Braille display, although there'll be still challenges. So we look at that efficiency, restrictions to computer Braille, not using UEB. So that means you're going to have to learn a completely different new Braille language, and there's no quick shortcuts to achieve things. So I always have this saying, humanware is, it's great that it's accessible, but the big question is it usable? And this is where we're introducing a new Braille-centric application for the Braille Note Touch called KeyCode. And the other piece here to remember is, once you start off with Code Jumper, what is the next step? What's that next path to coding? And I think a really useful tool is, of course, KeyCode, which is a new application that we brought out last year on the Braille Note Touch Plus. There isn't any Braille-specific tool out there at the moment other than KeyCode. And this really starts to introduce all those principles that you've learned from something like Code Jumper to actually start doing text-based coding, and in a more efficient and a Braille-centric way. So if we have a look at KeyCode, so as I mentioned, it's a Braille-centric coding app. It's optimized for the Braille notes. It's designed for Python script. It's simple to use, it's efficient to use, and together with a microbit processor. Now, you may not have heard what a microbit is, and I'll touch base on what that is on my next slide. But with this microbit, it makes coding so much more fun and engaging. And of course, most importantly, it gives you the tangible results that you need for someone who's blind. Having something that you've just changed and knowing what you have changed and getting that feedback is what we all want, right? When we want to change something, making something to look better, we want to see the outcome. So with KeyCode, you can be creative. You can create your own code fully in UEB contracted Braille. So there's no need to learn computer Braille. Why introduce a new language for someone who's young when they've already learned UEB contracted Braille? By all means, you can switch to different Braille codes. So if they don't know contracted Braille, they can do uncontracted. And if they do computer Braille, by all means, you can go to computer Braille. So you can toggle between all those various different grades of Braille if required. You can open existing Python codes. So imagine all of your fellow students or your study peers are maybe creating some code. And in the real world, what happens when you're doing coding, you'll then pass that code on to someone else to validate the code. So they do some checking. And this happens at Humanware. So once someone's written on some code, they then have to send it to someone else to validate the code, see if that can be improved, see if it's a good techniques that they've created. And the same thing here can happen. So you can actually share the code, and the user on the Braille Note Touch could actually maybe edit it or perhaps further improve that code or add something to that code. And then lastly is the debugging, which is crucial, right? When we're looking at coding and there's some errors and it's not working right, we need to debug the code. So in KeyCode, what's really unique here is that it does show on screen for the visual peers the line numbers. Now, line numbers are really important because you need to navigate to the line that has the error. And so on the screen, and we'll show that in a moment on a demonstration, you'll be able to see the line numbers. For the Braille user, that won't be immediately there. However, at any point, you can request the line number. So if you're not sure where you are, you can request which line I'm at. And of course, you can go to specific lines as well. Now, KeyCode has been designed around the established microbit. And we believe KeyCode is that next stepping stone to becoming a successful computer programmer. I will mention, though, that KeyCode at this stage is not a full IDE. Now, what I mean by IDE is an integrated development environment. So all the likes of Visual Studios, Android Studios, they are fully integrated development. And the KeyCode is really just at the very beginning, at the very start. So it doesn't allow you to kind of auto-select modules and things like that. So it's really very basic, but it's a really basic tool to get you started before adventuring into those other applications that are not so usable or friendly at a young age. You may probably be asking about why are we deciding on the Python? Well, Python is, as I mentioned in previous slides, it's an excellent first text-based language to learn. As I mentioned, the instructions and are all in syntax. They're all based in natural language. It makes code easy to read, understand, and modify. And as well, it's being widely used in education, but it's also used in industry, right? So especially in areas of data science and machine learning, Python is the way forward. Okay, so I'm going to introduce you to the microbit. Now, some of you may have heard the microbit. I think back in, maybe it was when they established 2016 or 2017, Microbit and the BBC, I believe, were promoting the microbit, and they're actually distributing the microbit in schools free of charge. I don't think that's the case anymore, but it was really just about promoting coding for all. Now, these little microbits are just a small circuit board. It's a small square-shaped circuit board, and it's got all kinds of different buttons and kind of connections on this little circuit board, very much like a Raspberry Pi. Okay, now there's different models of the microbit. They first introduced the version 1 microbit back in 2016 when it was established, but it wasn't really accessible at that point. However, version 2, which was launched maybe 2 years ago, they introduced the version 2 microbit, which actually had a speaker and all kinds of things that allow you to adapt that, so you could plug in speakers. So at that point, you can start to get some tangible results. But what's great about these is that they work with peripherals. So you can program these little circuit board, and then they can plug in to different types of robots and machines, which are available from Amazon's or the microbit site themselves. And you can do all kinds of different lessons with these. So it's a pocket-sized little computer, and it has two buttons, two physical buttons, A and B. And in between A and B, we have LED lights that can be displayed. We have an accelerometer. So you can do all kinds of programming where you could potentially shake the device and set an alarm off. And there's dedicated online resources to guide you through coding on the Microbit's Foundation's website. So it's a full curriculum. There's different projects, and I really urge you to have a look at their website. It's fantastic. They've got a lot of resources on how to start learning to code and get engaged with doing certain tasks, like how to program a talking watch, for example. So you can do a lot on its own with just this device. Maybe it's a compass, a talking compass, and maybe it's an alarm. So I've got some of the little things that we can do here on my slide: a sound compass, a tilt alarm, talking watch, a light alarm, guitar chords. That's just the start. But then, of course, you can start adding additional accessories. So on the bottom left corner here, I have an image of a robot. You can actually make the robot move. You can make kind of a merry-go-round, a wheel, all kinds of stuff that you can do that gives you those tangible results. And one of the things I'm going to do just beforehand is show you some of the limitations. Okay, so I talked about one of the things that we'll learn is some of the challenges that we'll face when we have a screen reader and a application involved. So I'm going to share my Python editor screen, share my sound. What we'll see here is I'm just using the microbit Python editor that's online, but it's going to give you an example of some of those challenges that young students can face if they've just got a braille display and relying on these third-party softwares. Before even learning how to code, right, the first thing you'll need to learn is how to use JAWS, how to use a screen reader. And I have to say, you have to be a very confident user to get by on this device, on using any kind of application or screen reader. Now, at some point when you do continue your journey with coding, and you see today that there's a lot of braille displays being used with screen readers, of course they're using script. So that means that you'd have to get someone in to actually script that application to make improvements in the application using your screen reader. But I haven't got any scripts. I'm just kind of out of the box JAWS here, and I'm going to navigate through
main region, code editor region,
some of those challenges. So the first thing, tabbing along around this is one of the things that you would probably expect it to do.
Right parent.
Let me just start at the top here.
App bot.
Okay, so I'm just going to tab around my screen here.
Discuss.
First thing we're doing is just trying to
help
explore, right?
List.
Explore.
View display documentation button.
And so as I'm exploring this whole page, there's so many different options for me, and I have no understanding of them unless I actually action them. So even if you're a confident user at screen reader, just
view buttons, view loops documentation button to activate.
So much information that is going through your braille display or through your ear at this point. So that's the first challenge, is just exploring and understand what these buttons are. You also have problems that some of the keys or labels may not necessarily be labeled correctly. And, so when you're trying to quickly navigate to maybe some graphics, so in JAWS, if you press the letter G, it will jump you to these graphics. It may not be labeled correctly. It may be labeled as a graphic, but it may not get you there. So there are some challenges there. Now I'm on this microbit Python. I've created a quick file that says from microbit import asterisk import speech.say hello world. That's the first thing that we always learn when you're learning coding, is to get your computer to say hello world. The other piece of information that's missing here is when I go and press the letter E.
Edit contains text. Wrapping to top. Edit contains text. Enter. Edit from
edit box now.
S blank blank.
Just correct that. It doesn't tell me information about my line numbers. So
import speech.
As I'm going up and down my lines of code,
from microbit import star. Import speech.
There's no information telling me what line numbers I'm at or how many lines that I have. Now, at this point, you'd have to probably just guess. So you'd have to understand what's on line number 1.
From microbit import star.
And then use your down arrow to
import speech. Speech.say. Left parent quote hello. World quote right parent.
The other piece is indentation, right? Indentation in Python is very important. And although you can do the indentation here, if you've got a braille display, you do have to start counting those indentations. So it doesn't tell you immediately how many indentations that you have. But nevertheless, I've written my code, and this is accessible, but it comes down to how usable is it. So I now need to try and find my kind of start compiler, or how I can run this code to see if it actually is a good code. Now, I do know from experience, and I know this website, that there is some kind of play simulator button. So again, you can have to tab along. Oh, actually, before I tab,
blank,
I need to get out
right parent, right
edit mode.
S blank.
Okay, so to get out of my edit mode, I have to use my virtual PC cursor, so my caps lock.
Virtual PC cursor.
And semicolon, and then I'll need to go to maybe a button. So let's press the letter B.
Center macro colon bit button.
And just keep pressing.
More connect options button menu collapsed.
Buttons.
Save button. More save options but open button. Collapse simulator. Touch logo button. Button A button. Button B button. Start simulator button. Okay,
so we have the start simulator button there, but again, you'll need to know what that is actually to continue using this.
So enter. Simulator button. Start simulator button.
Sorry,
To activate.
we jump there, but let's just run the code. So if there was an error in my code at this point, it would actually give me some errors. So let's have a look at that. Let's have a look. How does a screen reader and maybe an application like this handle those situations? So I'm going to go back into my edit box.
Wrapping to top. Edit. Contains text.
Edit box.
Enter. Macro::bit Python editor document. From.
And I'm going to take out one of these
H.
quotation marks.
Hotel. Quote.
Okay, so I've taken out one of my quotation marks. So I know from experience that I should be getting an error message here, but if you're learning how to code and you perhaps maybe missed that or forgotten it, let's see how we can find that if there is an error in our code. So again, we need to go to that button, which that button is like a checking your code option. So let's do our caps lock and semicolon.
Virtual PC cursor.
And we're looking, we can do B to go to all the buttons, or at this point, you know, again, experienced users, they can press Control F.
Virtual find. JAWS find dialog.
Start.
T. Enter. Type and text. Start simulator button.
And it will take you there. So that is a little bit quicker. But again, you need to be really confident on this. So I'm going to press enter on the start simulator button.
Enter. Simulator frame. Start simulator button. To activate, press enter.
Right, so I've just pressed the start button, but it hasn't given me that hello world again, right? So something's wrong, but it hasn't told me what is wrong. So again, you need to go searching. You need to explore around this whole site to actually explore what the problem is. Visually, we can see this, that on the just directly under the microbit simulator, there is like a purple line that says line 3 syntax error. Now, again, I need to navigate to that. And once you start to understand this website, there are some quick ways that you can get to that. So you'll know that if there's a mute button.
Button A, button graphic. Button B, simulate, reset, mute button. So to activate, press enter.
What you could do is search for the mute button, and then you know that directly after the mute button is
simulator serial terminal region. Show serial button. To activate
is the actual where the line begins to show you those errors. So although it's achievable, this is what we get when we have these third-party applications. They're accessible, but it's the big question is how usable they are. So I'm going to share my screen now and introduce KeyCode. So let me exit this screen and shut down JAWS.
JAWS Professional. Quit JAWS.
HCALAP 265 connected.
Okay, so I'm now sharing my screen of my Braille notes. That should be coming across.
Main menu, contacts,
And
key
you
list.
should have the speech as well. So KeyCode, right? So KeyCode is actually under the All Applications menu. So to get to KeyCode from my main menu, I'm going to press letter A.
All applications.
And select.
Main menu, all apps. Braille terminal.
And under my All Applications, I can jump to the letter K's by pressing the letter K.
KeyBRF.
And then I can use my thumb keys to jump until I get to KeyCode.
KeyCode.
Okay, so in KeyCode then, I'm going to open KeyCode up.
KeyCode.
We have
Create.
3 different options here. So create if we want to create our code, open if you want to open any pre-existing code, and we have settings. Let's just touch base on what's available
Open.
in settings for now.
Settings menu. Show warnings, tick box, not ticked.
Right, we have 1 options in settings called show warnings. There are 2 different types of, let's say, warnings and errors, right? So there's errors and there's warnings, and there is a difference. Warnings are warnings that will kind of tell you that, oh, I'm not sure if what you've just typed from a module is correct. So if you've used microbit, as I mentioned before, we haven't got a fully integrated development environment. So what will happen is you'll get loads of warnings to say, I'm not sure if this is correct. Please check to make sure, because I have no reference to a library to check. That's what the kind of the Braille note is telling you. So I certainly would recommend after using this is certainly disable those show warnings because they're not as important at the very beginning. But what is important is error messages, right? So if there are errors, then there's definitely an error in your code. There's a syntax error, meaning that you've missed something out. So whether it's a quotation mark, a left parenthesis or right parenthesis, something is missing in that code, and that's really important.
KeyCode. Settings.
So we're going to create something.
Open. Create. Edit box.
Okay, so first thing is when I create, it's very much like the word processor. So on my braille display, I'm only seeing my edit brackets with my cursor routing key on the cell as well, ready to type. So I don't see the 001. So on the screen, those that are sighted can actually see on the on my first line that I've got 001. So this will display your screen, your line numbers. And if at any point that the user wants to know what line number they're at, they can do the shortcut of where am I. But let's have a look at some of these shortcuts that are available, because you're not going to remember all these shortcuts initially. So the great thing about the Brown Up Touch Plus is that we have our contextual menu. So space and M.
Context menu. Find space with F.
And we're going to go through some of the things that we can do. So this is the context menu is a great way to learn the applications. This will apply everywhere on the Brown Note Touch Plus, not just on KeyCode. So these are the things that we can do within this application. So we can do a find, space with F. That could be quite useful if there's a certain word or sentence that we need to find within our code. And maybe if it's repeated, we can then find the next.
Find next, space with N.
So, or we can find the
find previous, space with P. Save, space with this.
We use the same shortcuts to save, identical to how you'd save within Keyword.
Save as, backspace with this.
You have the save as well. So if you made any changes to your code, we can save it, or maybe you want to rename it or change the directory of where that file has been saved. You can do that.
Go to line number, enter with G.
Go to line number, really important. So let's say let's say you're doing a debugging class, right? And on purpose, they do something, they tell you to type something incorrect, and then they show you how we need to change this. You can quickly go to that line number. So imagine having hundreds or 200s of line of codes, right? It will be a nightmare to just keep tapping and scrolling through all those lines of code. So a quick way is enter with G, and it will ask you to type in the line number that you want to go to.
Enable reading mode, space with X.
Enable reading mode, space with X. Again, this is available in our Keyword and our KeyBRF applications. What's really useful about this is if you're reading code, maybe it's from someone who's just shared a Python code to a student, and they just need to read it just to see, maybe it's they're checking the code. So this will avoid any kinds of edit in that code. So space with X is a toggle, so it'll toggle you between the reading mode and then editing mode.
Compile code, enter with C.
Compile code, enter with C. This is really important. So once you've finished writing your code, we want to check our code. So like I showed you using the screen reader and the microbit Python editor, I had to go to the Start Simulator button. That Start Simulator button is like compile code. It checks your code. And this is what we have here. It's a compile code, enter with C. And if there are any errors, it will list those errors in a full list, and you could then explore those errors and click on those errors, and it will take you to the specific line. So again, making it more usable for you. So that's something we'll cover in just a minute.
Flash code on the device, enter with F.
Flash code on the device, enter with F. This is when your code is compiled correctly. So if you're happy with your code and you then want to flash your code, you're flashing it to the little microbits. So I'm holding that up on I'm not sure you can see yet. The little microbits that I'm showing here, that's what you're going to flash it to. What that does, it kind of changes it from a Python file to a hex file, right? And so when you're looking at coding on these little processors, they all follow all these numbers, your ones and your zeros, and so it needs to be in a hexadecimal file. So that's what flashing the code does. It converts the Python code to the hex file. But also when you're compiling your code, it will prompt you to save as well. So once you've compiled your code, it will prompt you, do you want to save your Python code?
Line information, space with dots 1, 5, 6.
So this is really important. Maybe you want to know what line number you're on, right? So I mentioned you can see it on the screen for our sighted peers and teachers, but for the user, that's not getting in your way. So we want to make sure that we can utilize all the braille that we can on our braille display. But at any point, if we want to know what line number we are at, we can by pressing the Where Am I shortcut, which is spaced with dots 156. That will give you information of what line number you're at and how many indentations that are available. As I mentioned, Python indentation is important.
Remove indentation, backspace with U.
And backspace review will remove any indentation. And I think that's pretty much it. Into indent, if you do want to indent, it's a tab. Okay, so it's backspace with the letter T to indent something. But if you want to remove that indentation, you can either press backspace review, or you can actually press the backspace if you've just accidentally just tabbed along. So let's continue and create some more code here.
Edit box.
What I will say is a lot of information available about KeyCode is available on our HumanWare Buddy application. So if you haven't installed the HumanWare Buddy application, please do. There's a lot of great resources on there. There's links to videos, there's notifications, and there are some sample levels as well, some coding examples that we have included. I've yet to update. Well, I've up to upload the Hello World one, but there are some other projects. I think there's one that how to set a tilt alarm up, and there's also another one, I think maybe the compass. But there are some projects examples there. So please feel free, have a visit in the Buddy app, and you can at least get started there. Okay, so I'm going to do exactly the same here as I did on the Micron Python editor on my website. I'm going to create the hello world. So I want my microbit to say hello world first. This is the first thing you'd always get told about. You can do a lot more with this, right? But I'm really starting basic here. I don't want to scare anyone. And I have to say, I'm not a coder myself, right? I've learned this from KeyCode. And of course, some of the resources that have been available through the Microbit Foundation site. Okay, so the first thing that we need to do on our first line is we need to import, so we need to put a line that says from microbit import asterisk. Now what this means, I'll tell you in a moment, but I'll just type this away. So we've got
from
microbit.
M-I-C-R-O-B-I-T, microbit. I-M-P-O-R-T, import. .5.35 asterisk.
Okay, so I've typed in from microbit import asterisk. So asterisk is .5 followed by dots 3 and 5 for those that know. So we're doing full UEB here. This first line is telling the device that I want to grab every bit of kind of modules that are available from my microbit library, right? So this is the type of library. Now, unfortunately, we can't install libraries on our Braille notes, and that's something I'd love to get on an upcoming version, is the ability to upload different types of libraries. But for now, we type in the first line is from microbit import asterisk. So import all of my modules available to me from the microbit library. Okay, second line, enter.
New line.
Now we want to import the speech, right? And I'll just type in import speech, and I'll tell you a bit more.
Are deleted. P-O-R. Import. Space deleted. T. Import. S. P. E. Dots 1 6. Speech.
Okay, so my second line is import speech. So what I'm telling the microbit at this point is I want to use the speech module. So I've asked the microbit I want to use or want to have access to all of the library available from my microbit. And in particular, I want to, at this point, I want to import my speech module, right? So press enter.
New line.
And my next line is speech.
S. P. E. Dots 1 6 dots 2 S. A. Y.
So speech dot say, and then we're going to do our left parenthesis.
Dot 5. Dots 1 2 6.
And I'll just explain this in a moment as I just type.
Dot 3. Dot E. E. D. A. E. L. O. Dot 2. Speech dot say single quote hello. Dot 6. W. O. R. L. D. Dot 3. Dot 5. .345.
Okay,
World.
so I'll explain what I've done here. So I've just typed in speech.say, left parenthesis, single quote, hello, comma, world, single quote, right parenthesis. So this line is saying, okay, I want to use the speech module because I've imported it already, but from that speech module, I then want to use the say command and then say the following. So in the parentheses, this is what you'd want it to say. Now you can change this, right? So once I've done this, you can then further adapt to the code. And we'll do that in just a moment. So I'm happy that I've got from microbit, and all of this is coming in my braille, all in UEB, and I can use my thumb keys to jump left and jump right. And I'm now ready to compile my code. So let's check our code. For those that don't remember, enter with C, but if you do forget, you can go into the contextual menu and you can action that shortcut. So enter with C is for checking my code.
File name edit box, new document.
Okay, the first thing it's going to ask you is to save because it hasn't saved it. So we're going to save this as a Python. So it prompts you to save it automatically into the documents folder, and it will bring in a new name, a new document. But I'm just going to type in hello.
ELLO. Hello.
Test.
T. S. S deleted. T.
Okay,
S.
and I'm going to press enter.
Saved. Compilation errors and warnings. No compilation error. Edit box.
So I did two things there. First of all, it prompts me to save it as a Python code. And the second bit is then it checks, and it gave me the message that there's no errors, which is great. So now I could actually flash the code by pressing enter with F. But before I do that, I need to plug in my microbit. So with your microbit, you'll get a USB A to a USB micro USB connection cable. So I'm going to plug this all in back of my braille note and then plug it into my microbit, and I'll change the camera here so you can kind of see what I'm doing. Those that let's see, I have to change my background. Okay, so here's my microbit, and I've plugged in my USB cable at the back, and on my micro USB end, I'm going to plug this in to the connector that's available on the microbit. Once I do that, the braille note's going to pick that up as like a memory stick.
BBC Micro, bit consist app, USB device attached.
Okay, so it's detected it already. It's announced it. I'm now ready to flash my code. And to flash your code, again, if you're not sure, you can go into the contextual menu, or if you do remember, it's enter with the letter F.
Saved. File name edit box, hello test.
Okay, what this automatically does now, it takes you into that file manager menu again. And what you will notice, those that are able to see the screen, is my file type is now set to a hex file type. Now, what I need to do is route this file to the microbit, right? So it's just like saving a file to a memory stick at this point. This is what I'd recommend all the time when you're using the file manager. I always would recommend your students to go to the very start, the very beginning. So by pressing space with letter D to choose your
drive selections. Drive selection.
Okay, so at this point, I'm at the very beginning of my file manager, and I want to choose my microbit. So I can use my thumb keys or my spacebar or first letter navigation to jump to the microbit.
Microbit, 66.97 MB free.
All right, so it's picked it up as a memory stick, as I mentioned. I'm going to press enter.
Hello test lost.director folder.
Okay, it's now taken me to the microbit directory. And if you put it in a folder, it gives you the option if you want to put it in a folder, but we're not going to put it in a folder. You can rename the file if you wish, but if you're happy that this is the file that you want to keep, that's fine. We can just go to the save button. So you could either use your thumb keys to navigate to the save, or the quickest way for those that are familiar with the file manager, and I know that we did change that last year as well, you can press your action button, which is a new shortcut that we introduced to action the save, backspace with the letter A.
Lost.director folder. Loading. Downloading code to microbit. Please wait.
Okay, so that's now downloading the code to the microbit. And once that's finished, it will say download complete, microbit ready, or what's that effect. In the meantime, you'll see the microbit flashing. Okay, now I don't think you even heard that, but
microbit ready.
With the microbit now, it's with the
Edit box.
speaker because it has got an onboard speaker. Now it's not the best onboard speaker, so you can buy accessories where you can have crocodile clips and put it into a connect your crocodile clips here and put it into an external speaker or even headphones. I was able to do this in a session in America actually, where I plugged it into the speakers. But I'm going to put it next to my microphone, and I'm not sure if you're going to hear this or not because of the frequency, but I'll give it a go. So I'm going to. Again, I'm not sure if you can hear that, but it is saying "Hello World" on with the onboard speaker. All right. But having said that, you can do all kinds of stuff. You can change the Hello World now. So let's have a look how we can do some debugging and make some of those changes quickly. So I'm back in my document here in my code, and I'm going to do some
dots 3.
I'm going to get rid of
dot space dot 2 L E H dot 6 deleted. Bottom.
that one. I'll go back in my braille again. I'm going to do the,
Selection cleared. Dot 3 deleted.
there we go.
Bottom.
I've got rid of that single quote. Okay, like I did with the Python editor on my web browser. So I'm going to do the same thing again here. I'm going to compile my code, and I'm expecting to have an error here.
Saved. Compilation errors and warnings. Failed to compile. Syntax error. YOLO while scanning string literal. Speech.say hello world.
Okay, so it has given me an error message. It's only given me one. Now I can, if there's multiple error messages at this point, you can use your thumb keys to go up and down. But I'm going to press enter on this one. And what it will do, it will take me to that line.
Edit box. Speech.say hello. Selection cleared.
Okay, it's told me that there is a syntax error. So we know that there is something missing. There's some kind of text or syntax that's missing or error that I need to correct. And as you're reading this code in Braille, you know, you'll then probably then sort of understand, oh, yes, I missed out that single quote. Okay. The other thing that you can do, let's say I'm at the top of my document, is you can use the go to. So let's say you as the teacher just saw that there is an issue with line 3. You can press enter a G.
Go to line edit box. Go to line.
And we then want to go to line number 3. So we do our number sign.
Dots 3 for C.
And 3. And press
Edit box. Speech.say hello. Selection cleared.
And it will take you to that line. So once you get your student to do this, you could then adapt, right? So we've got hello world. Now you could then say, okay, let's do something else. Instead of doing hello world, let's say, hello, Andrew, welcome to today's session, or just do other things like that. And there are other things that you can then start to do where if you want, you can actually start to display icons on the LED if you wish, right? You know, you can use those, although they're not tangible. You know, if you want to then start to add more towards this code, you can then start to import the display module as well. But all of this information is available from that foundation site, and there's some examples of code. So, I mean, examples of what I've done, for example, is actually taken down one of the hex files and just loaded it onto my Braille note, right? So all those complex ones, you can then start to understand it yourself. So yeah, that's it from today. I mean, that's the key code. So just to run through a couple of things, you know, we can open up code, existing code here. We can save our code. Context menu, space for M.
Context menu. Find space with F.
This is where all of those shortcuts are available. So you'd compile your code, enter with C, which checks your code, and then to flash it, enter with F, and just make sure when you're flashing your code that you're saving it to the microbit itself. Okay. So we have 5 minutes left. I'm going to open the floor to questions. So if you have questions, please post them in the chat, post them in the Q&A. I'm also going to like to raise your hands. If you want to raise your hands, you can press Alt+Y or hit the raise hand button. So let me just check and make sure that I've got that. And then I'll request for you to unmute yourselves. So yeah, you can raise your hands. If you do want to have to speak to me, you can do now. So just raise your hands and I'll unmute yourself. Or as I mentioned, post them through the chat. So let's have a look through the chat here for some questions. So first question, will the Braille note work with both version 1 and version 2 microbit? Yes, it will. So the version 1 microbit, it will work, but just remember the version 1 doesn't have the onboard speaker, but nevertheless, you can still program those microbits and put those version 1 microbits onto those additional peripherals, right? As additional robots, etc. So this presentation, thank you. Since the website you use is not incredibly usable in some ways, have you reached out to the manufacturers and developers? If you've explained the issues, maybe they'll be willing to improve it. Maybe those of us who are interested in coding for the blind need to reach out to them and ask them to please make changes. It couldn't hurt. It's a very good question, and we have, but this is what you'll get from a lot of different third-party companies. It's accessible from their point of view, right? And that's all that they are kind of bound to do, is make it accessible. It's not going to be possible for them to make shortcuts, right? Remember, all of these applications are built and designed for a sighted world, right? And then after creating this, they then just make it accessible by making it so that items are clickable and you can navigate around. And that's what we can do, right? So it is accessible, but it's that usable message. Where do we buy the microbit device from? Very good question. So microbit site themselves, so you can go to microbit.com or Amazon. Amazon, actually, you can buy a couple of things from Amazon. You can even buy the robots and additional kits. Just be careful when you're buying them from Amazon that sometimes if you're buying a robot, it will say without the microbit, and there might be another price that says with the microbit. Okay, so just be aware of that. We are looking at another site that we may be able to get the microbits, but that hasn't been announced just yet. But we won't be selling them directly. Okay, so for the meantime, I definitely recommend you getting them from Amazon. Okay, so don't know about the Microbit Foundation. Yeah, definitely really encourage you to have a look at that, the Education Foundation. It's a fabulous site. So it's got all those resources and examples of different codes, and there's some projects that to get you started. Thank you very much for joining me. And if you have any other questions, please feel free to reach out to me. My email address is andrew.flattress@humanware.com. I'll just post that into the chat. Okay, so please feel free to send your Q&As. If you're not able to post your Q&As on here, to me, and I'll do my best to answer. So thank you very much, everyone, and have a good rest of your Friday and have a great weekend. Take care.